Hello everybody. Today we are going to be reviewing your quarter one assessment, and then if you guys have any questions, please go ahead and email your teachers so that we can help you guys, okay? So the first thing we're going to talk about is exponents. Remember, when you are trying to solve an exponent, this does not mean you're taking the base times the exponent, okay? This means that you are going to multiply this, your base, times however many times it's telling you. So in this case, 2 to the third power means that you're going to take 2 times itself 3 times. So in other words, 2 times 2 times 2. And if you were to evaluate that, 2 times 2 gives you 4. And then multiply that times 2 again, and you should get a value of 8. So same thing over here. 3 to the fourth power means that you're taking 3 times itself 4 times. And then you can break it down, so 3 times 3 gives you 9, this 3 times 3 gives you 9, and then 9 times 9 gives you a value of 81. Alright, this next one, write 3 to the fourth power as a product. So all that means is instead of solving it, you're just going to write down the product. So 3 to the fourth power means you're taking 3 times itself 4 times. And that's all you have to do. So whenever it's telling you to write it as a product, remember, product means multiplication. So you're just showing me what are you multiplying, okay? And then same thing as 5 to the third power, you're just going to take 5 times itself 3 times. And then since it's just asking for the product, that's all that you need to write down. Alright, moving on to the second part, name like terms and simplify. So the way that I taught my class was to use the boxing method. So whenever you guys use the boxing method, you are boxing in every single term as well as the operation that's before it. So that whenever you guys see subtraction signs, it's easier to see the subtraction signs as negative signs, and it's easier to identify your like terms. So in part A, my like terms are 9x and this negative 4x, since they both have x's to the same power attached to them. So I'm just going to write 9x and negative 4x. And then that plus 7 is all by itself because that's my only constant. So I'm just going to write the 7 over here by itself. And then when you go to simplify, remember that you can only simplify like terms together. So I can only simplify this 9 plus my negative 4, or in other words, 9 minus 4 to give me a 5x. And then since the 7 is all by itself, there's nothing to simplify it with, so I'm just going to drop it down with my expression. So we'll do the same thing over here for B. I'm going to box in all of my terms and include the operation that's before it. And then now I can identify my like terms. So my like terms here are 8x and x, since they are both x's to the same power. So 8x and x. And please don't forget that if the variable is by itself, you can put an imaginary 1 before it. So over here I'm going to put 8x and 1x. This minus 7y or negative 7y is all by itself, so I'm just going to include that over here by itself. And then same thing with that negative 20, because that's my only constant that I have, okay? So when I go to simplify, I can only simplify like terms. So in this first parentheses, I can simplify 8x plus 1x to give me 9x. And then since this negative 7y and negative 20 are by themselves, I'm just going to drop them down with a 9x. So that's what I should get. Or if you change this to adding a negative, you can do that as well, okay? Alright, C, so I'm going to go ahead and box in my terms as well as the operation that's before it. And when I go to identify my like terms, notice how I have x squareds as my variables here. So all 3 of these terms are like terms since they all have x's to the same power. So 2x squared, negative 6x squared, and 3x squared are one set of like terms that I have. And then this 7's all by itself since that's the only constant that I have, okay? So when I go to simplify, I'm going to simplify my like terms together. So if I were to take 2 plus negative 6 plus 3, well, 2 plus 3 gives me 5, and then 5 plus negative 6 gives me a negative 1. So all of this will equal negative 1x squared. And then since this 7's by itself, all I have to do is just attach it down here at the bottom, and I now have negative 1x squared plus 7. Alright, and our last one, so I'm going to box in my terms, make sure I include the operation that's before it. And looking here, it looks like my 7x squared and my 2x squared are like terms. So over here, 7x squared and 2x squared. And then notice how I now have two constants. So this negative 10 and 5 are like terms because they have no variables attached to them and they're just my constants. So constants will always be like terms together. So this will be negative 10 and 5. Alright, so when I go to simplify, I can only simplify my like terms. So if I were to take 7x squared plus 2x squared, that gives me 9x squared. And then if I were to add my constants, negative 10 plus 5, since they're different signs, I'm going to subtract. So 10 minus 5 is 5. 10 is bigger than 5 and it's negative, so it's going to stay negative. And this is the same as just 9x squared minus 5 as well. Okay. So with like terms, remember, box in your terms. You can only simplify by combining like terms together, and then just watch out for those negatives, so use your integer rules. Alright, next part is square roots. Remember, square roots are, if you were to find the square root of 64, you are trying to figure out what number times itself will give you 64. So if you're thinking the square root of 64 would be 8, because if I were to take 8 times 8, that would give me my 64. With 49, 7 times 7 gives me 49, so the square root of 49 is just 7. The square root of 36, if I were to take 6 times 6, that gives me 36, so the square root of 36 is 6. And then the last one, D, the square root of 16, 4 times 4 gives me 16, so my answer here is 4. Alright, evaluating expressions. So we are going to evaluate n minus 12 for n equals 30. So remember, this is when you're going to plug in the value of the variable into the variable in the expression, and then you're just going to rewrite the problem. So if I were to plug in 30 for n here, this will now be 30 minus 12. And then now all you have to do is just solve it. So then 30 minus 12 gives me 18. So my answer here is 18. Alright, evaluate x times y when x is negative 3 and y is negative 14. So same thing, you're going to plug in negative 3 for x, you're going to plug in negative 14 for y, and then the operation, that dot, is telling me to multiply. So if I plug in negative 3 for x, I'll have negative 3 times, plug in negative 14 for y, and now I just have negative 3 times negative 14. So if I were to take 14 times 3, I get 42. And then if I were to use my Christmas tree to figure out what a negative times a negative would give me, remember, you just cover up negative times negative, and then whatever you have left will be the value of your answer. So negative times a negative gives me a positive. So this will be a positive 42. Alright, next one. So evaluate 4x plus y when x is negative 5 and y is 24. So you're going to do the same thing. You're going to plug in negative 5 for x, you're going to plug in 24 for y, and then just rewrite the problem. And you guys need to remember that when a number is shoved up next to a variable here, that means that you are multiplying. So I am not just going to plug in negative 5 here and write this as negative 45. This means I'm going to take 4 times negative 5 to give me my answer. So plug in -5, and I'm just going to use parentheses to demonstrate that multiplication, because anything shoved up next to a variable or parentheses means that you're multiplying. And then when I plug in 24 for y, it would just be plus 24. And then now I'm going to go ahead and solve it. So think of PEMDAS, order of operations. I have to do multiplication first before I add. So 4 times -5, well, 4 times 5 is 20, and then a positive times a negative, looking at my Christmas tree, a positive times a negative will give me a negative. So this now becomes -20 plus 24. And then using my integer rules, I have a negative plus a positive, so I have different signs, which means I'm going to subtract. 24 minus 20 is 4, and since 24 is bigger than 20 and it's positive, my answer is going to stay positive. Alright, and then this last one, evaluate y minus x when x is 10 and y is -3. So again, plug in your values where they belong at in the expression. So y was -3, so it's going to be -3 minus, and x was 10. Now remember, back to your integer rules, I told you guys to always change subtraction to addition and add the opposite. So if I were to change subtraction to addition, and the opposite of a positive 10 is a -10, I now have -3 plus -10. So since I have same signs, I'm going to add. So 10 plus 3 is 13. And since I'm adding two negatives, I'm going to keep my negative sign. So that should be -13. You guys know that you guys can pause this video at any time if you guys need to catch up, but I'm just going to go ahead and move on. Alright, integers. Remember your integer rules. So when adding and subtracting, you are trying to figure out if you have same sign or different signs, and then that will take you from there what you're supposed to do. So in this case for A, I'm adding two negatives, which means I have same sign. So I'm going to add my numbers like normal. So 6 plus 3 gives me 9, and since I'm adding two negatives, I'm going to keep my negative sign. For B, when we talked about subtraction, just like we did on the first page, you always want to change subtraction to addition and then add the opposite. So if I were to change subtraction to addition and add the opposite of a positive 8 is a -8. So -3 minus 8 is the same thing as -3 plus -8. So I'm adding two signs that are the same, so I'm going to add like normal. 8 plus 3 is 11. And since I'm adding two negatives, I'm going to keep the negative sign. Alright, C, find the product of -7 times 5. So multiplication, you're just going to multiply like normal. So 7 times 5 gives me 35. And then to figure out the sign of your answer, this is when the Christmas tree comes into play. So if you're taking a negative times a positive, you're going to cover up one negative, cover up one positive, and then whatever you have left will be the sign of your answer. So in this case, it will be -35. When you're trying to find the sum of multiple numbers, just take it one step at a time. So if I were to take the first step here, so -6 plus -2, this would give me -8 since I have same sign, so I'm going to add like normal. And then I'm going to attach this +3, so when I have a negative plus a positive, I can now subtract my numbers since I have different signs. So 8 minus 3 gives me 5, and then since 8 is bigger than 3 and it's negative, my answer is going to stay negative. Alright, so this will be part 1 of the video. I'm only allowed 15 minutes of this video, so I'm just going to go ahead and stop. So catch up on all the problems that you need to, and then please move on to part 2 of this video to get the rest of the answers. Thank you guys.